Recording is on.
Adnan, I can't see your
Yeah,
screen.
sorry. There was a recording issue. I was fixing it. Can you see it now? Sorry. Yeah, can you see it now?
Yeah.
Okay, sorry guys.
Okay, everybody. Once you guys are finished with these two problems, just please type in the chat, or if you don't know how to do them, just type in the chat that you're stuck or you finished the problems. Thank you. Adnan, can you full screen?
Yeah.
Okay, Adnan. Quite a few people have done both or either one of the problems. Can you please explain number 3 and 4?
Okay. So let's see. Let's go back to number 3. So Brian is a window cleaner. He uses the following formula to calculate the amount to charge his customers. The charge equation is 20 plus 4n, where n is the number of windows a house has. If a house has 7 windows, how much would Brian charge? So let's go back here. So let's see. So the equation we were given is 20 plus 4n. That would be the total cost, right? So we see that n is the number of windows a house has. And we also know that the house we are looking at has 7 windows. So we know that n is equal to 7. So our new equation would be 20 plus 4 times 7, because it would be like $7 for each window. So then we first do multiplication. So that'd be 28. And the answer would just be 20 plus 28, which is 48. It's the answer for number 3, $48. Okay, so number 4, Jamie's dad is 4 times older than Jamie. In 14 years, Jamie's dad will be twice the age of Jamie. So what's the sum of Jamie's age now and Jamie's dad age now? So let's say that Jamie's age is equal to X, okay? And Jamie's dad, so that means Jamie's dad would be 4X because he's 4 times as old as Jamie. So, and then it says in 14 years, Jamie's dad will be twice the age of Jamie. So that means 4X, which is Jamie's dad, plus 14 would be twice the age of Jamie. That means 2 twice the age of Jamie. 2 times X plus 14. Okay, then we have to distribute the 2 to both numbers, so it'd be 2x plus 28 is equal to 4x plus 14. Subtract 2x from both sides. You get 2x plus 14 equals 28. Then subtract 14 from both sides, you get 2x equals 14 and x equals 7. So that's Jamie's age, okay? We want to know the sum of Jamie's age now and Jamie's dad's age now. So that means, okay. So Jamie's dad's, so we know Jamie's, okay? And Jamie's dad would be 4 times older than Jamie. So we just do 4 times 7, which if you know basic multiplication, 4 times 7 is 28. Add that with 7, and boom, you get 35 years. That's your answer. Okay. Yep, there are the answers. Okay, so let's go over some vocabulary you're going to want to know for this lesson. So divisibility rules. These are methods for determining if a number is divisible by another without full division. It's like simple tricks you can use to find if a number is divisible by another number. The greatest common factor is the largest positive integer that divides 2 or more numbers without leaving a remainder. Which means like, the least common multiple is the smallest positive integer divisible by 2 or more numbers. And prime factorization is the process of breaking down a composite number, into a set of prime numbers, which means numbers that are only divisible by themselves in 1, that multiply together to equal the original number. So just breaking down the numbers into smaller prime numbers. You'll see where that's useful later. Okay. So let's go over some divisibility rules. So let's start with number 2. A number is divisible by 2 if the last digit is even. So the even numbers are 0, 2, 4, 6, and 8. So like 1594, it ends with 4, which is an even number, so it is divisible by 2. So, okay, next one, number 3. A number is divisible by 3 if the sum of the digits is divisible by 3. So like 213, you can see 2 plus 1 plus 3 equals 6. It's pretty cool, not gonna lie. You just add the digits, right? So let's move on to number 4. Number 4, the last 2 digits are divisible by 4. Okay, so it's divisible by 4 if the last 2 digits are divisible by 4. So you see 3412. Take these last 2 digits. You see if it's divisible by 4. It should be easy. 12 divided by 4 is 3, and it's divisible by 4, so yeah, 3412 is divisible by 4. Moving on to 5, it's divisible by 5 if the last digit is 0 or 5. So that's pretty easy. 1045 it ends with 5, so that means it's divisible by 5. Pretty simple and easy, right? Okay, so next column, number 6. Number is divisible by 6 if the number is divisible by 2 and 3. So 408, if you want to go back to 2 and 3, it ends with the even digit, so it's divisible by 2. And the sum of the digits is divisible by 3. Well, let's check. 4 plus 0 plus 8 is 12. 12 divided by 3 is 4 with no remainder. So yeah, it's divisible by 3. So that means since it's divisible by 2 and 3, it is divisible by 6. Now for 7, there's no set method to find if a number is divisible by 7. That's pretty simple and easy. So we're just going to skip number 7. So for number 8, if the last three digits are divisible, if a number is divisible by 8 if the last three digits are divisible by 8. So instead of number 4, you had to look, instead like number 4, you only have to look at the last two. For number 8, you have to look at the last three. So 120 divided by 8. So 1120, look at 120. Can you do 120 divided by 8? Yes, that equals 15. So that means it's divisible by 8. So moving on to 9, is divisible by 9 if the sum of the digits is divisible by 9. It's the same idea as number 3, really. So look, 5,418. 5 plus 4 plus 1 plus 8 is 18. And we know that 18 divided by 9 is 2. So that means it is divisible by 9. So yes, 5,418 is divisible by 9. Okay, so for number 10, it's really easy. It's divisible by 10 if the last digit is 0. So 9,050, it ends with 0. So that means it's divisible by 10. Okay, now last one, number 12. The number passes, it's divisible by 12 if the number passes both rule 3 and 4. So 144, is it divisible by 3? Let's check. 1 plus 4 plus 4 equals 9, and 9 is divisible by 3. So, yeah, okay. Now, number 4. The last two digits are divisible by 4, so let's look. 44 divided by 4 is 11, so it's divisible by 4. So, since it passes both rule 3 and 4, it's divisible by 12. Okay, next slide. Okay,
Wait.
now let's talk about prime factorization.
1 second. Everybody, did you guys write that down for notes? Did you finish writing that? Could you type it in chat if you have? Okay, that's good. Right. Adnan, could you just hurry up a little bit?
Okay,
Otherwise, good. Yeah. All right, everybody's done with it.
okay. So let's move on to prime factorization. Prime factorization is the process of breaking down a composite number into a big number into a string of prime numbers when multiplied with that when multiplied together equal the original value. You can think of these prime numbers as the building blocks of that specific number. So like look, prime factorization of 12. So you can take out 2, 2, and 3, which are all prime numbers because they're only divisible by themselves and 1. These are like the building blocks to 12, as the definition says. So let's have some questions. I'm gonna give if y'all understood that well, I'm gonna give you some questions you can do by yourselves. So, what is the full factor form of 18, and what is the full factor form of 40? I'm gonna give you 3 minutes again to solve both of these problems. If y'all are done, you can type it in chat. Remember, prime factorization is just the building blocks of that number, and it has to be made up of prime numbers. And prime numbers are numbers that can only be divisible by themselves and 1. Okay? Other questions?
again, when you guys are done, please make sure to type in chat that you're done so we can know so we know to move on.
Okay, guys. So I've seen y'all are most of y'all are about done with this, so I'll go over them. So let's look at question one. Question one: what is the full factored form of 18? Okay, let's move over here. 18. So do we know the factors of 18? They are 2, 9. Okay, that makes up 18. 2. So 2 is a prime number, so we can keep this prime number. 9 is not a prime number. It's actually divisible by 3. So let's see. 9 is 3 times 3, which 3 and 3 are prime numbers. Okay? So we know that the prime factorization of this would be 2 times 3 times 3. Sorry guys if my drawings are not neat. I'm writing on mass, but I'll try to make them neater. Okay, so that would be the full factor form for question 1. So let's make this a little more exciting. Can anyone tell me the answer to question 2? Y'all could just raise your hand. Press the raise hand button.
Vivon, you can.
You can
I
answer
saw
the
your hand.
question.
Yeah.
2 times 2 times 2 times 5.
Adnan, I think you're muted. I can't hear you.
Oh, sorry. Okay. So let's see. So he was correct. This is the prime factorization, as all these numbers are prime, and they equal to 40. Okay. 2 times 2 is 4. 4 times 2 is 8, and 8 times 5 is 40. So yeah, good job. Okay, we'll move on to the next slide. Let's learn about the greatest common factor. All right. So the greatest common factor is the largest number that divides 2 or more values exactly. It represents the biggest shared divider between numbers, which is essential for simplifying fractions. You can use the divisibility rules from before to quickly identify these shared factors. You can use prime factorization to find the greatest common factor of two numbers by decomposing each number into those prime factors and then multiplying the lowest powers of each shared prime factor. The resulting value will be the greatest common factor. So let's look at some examples. I'll do the first one with you, and you guys can do the last two. All right. So number one, what is the greatest common factor of 50 and 15? 50 and 15. All right. So let's see. It's had to use prime factorization for this. So we know that 50 can be divided into 5 and 10, and 10 can also be divided into 5 and 2. So the prime factorization would be 5 times 5 times 2. Try to X this. All right, and 15. Its factors can just be identified as 5 and 3. So it would be 5 times 3. Okay, so let's see. We got 5 squared. So 5 and 5, you can actually simplify this to 5 squared. It's another way of saying 5 times 5 times 2. And you just have 5 times 3 over here. So let's see what it said to find the greatest common factor. So we decomposed each number to its prime factors and then multiplying the lowest powers of each shared prime factor. So this is the lowest power. And so first of all, we have to detect which one is shared. 5 is in both of these, so that's shared. 2 is only 1 and 3 is only 1, so they aren't shared. So the lowest power of the prime factor. So this would just be 5 to the 1. So this would be the lower prime factor. So your answer would just be 5. So remember these steps. Decompose each number to its prime factors. So then write it like this. If they're similar, just count how much terms and put it in little at the top right corner like that. Make sure they're shared. Make sure the numbers you're looking at are shared. Then take the lowest power from that. If there are 2 or more powers that are low, just multiply them together. Okay? So let you do 2 and 3 by yourselves. Just type in chat whether you're done or not. So yeah. Okay, so guys, so I've seen most of you pretty much done with these two. So, Birnam, I see that you said you were finished first, so do you mind giving us the answer to question number 2? Like, what did you get? You can unmute and say it. Okay, I don't know if she's here, so Yojith, you were the second one to respond, so do you mind telling us the answer, what you got for question number 2?
I got number 7.
You got 7? That's actually
Yeah.
that's correct. Good job. So let's see how we got it. So 21, 14, that's 7 and 2. This is 7 and 3. 7 is shared. There's no lowest one, so you just take 7 to the 1. That's 7. Good job, Yojith. Does Does anyone know question number 3? You can raise your hand and just raise your hand. Oh, Ashant, looks like you raised your hand first. Can you tell us that what you got for question number 3?
I got 3.
3?
Yeah.
Okay, let's just check your answer. 63 and 42. Okay, so let's see. 63 now is equal to 9 and 7. 9 is also 3 and 3. 42 can be split to 7 and 6. And 6 can be split into 3 and 2. So it's just, I'll write it in text so it's easier for y'all to see. Mm, you have 3 times 3 times 7. And then you have 7 times 3 times 2. Got that right? Okay, so let's see. So 7 and 3 are shared, so we can ignore the 2. The lowest power. So this would actually be 3 to the second. So Sean, you said 3, right? But we can also see that 7 is actually in both numbers. So we also have to take that too. So I think you got confused on what to do with the 7 because you didn't see a lower one. So what we actually do here is multiply these two lowest powers, and that would give us 21 as the greatest common factor. Okay, it's okay though. Still, good job. You guys did it. All right. So next slide. Let's learn about the least common multiple. So the least common multiple is the smallest possible integer that is divisible by 2 or more numbers without leaving a remainder. It's like the smallest shared number in like given set numbers or in any two numbers. It's a small shared multiple. You can use many methods to solve for it, but today we're just gonna use prime factorization to solve it, okay? I'll do the first one. So what's the lowest common multiple of 2 and 7? Okay. So hey, I'll do this one with you. Y'all can do the second one. You'll get it easy, don't worry. Okay. You have 2 and you have 7. So really you can't really split these numbers apart. They are prime. So really all you have to do, since you have to find the multiple, you just times them together. So 2 times 7, 14. It's that simple, guys. Y'all got this. Okay. So y'all can just do number 2 by yourselves. Number 2 actually works a little bit differently. So remember, it's not just times them both together and that's the number. The number has to be as small as possible while still being able to be divided by those numbers. Okay. So y'all can do number 2 by yourself. Uh, Once 3 people are finished, I'll call on the first one who typed. Okay. Okay, Vernam, you were the first one to type, so could you tell us what you got for question number 2? You can unmute if
12.
12. Good job. That's actually correct. Let's see how you got that. 4 and 6. So you actually can divide that by. You can actually divide both numbers, factor it. Also, I realized that isn't Vernim, that was someone else, but still good job to both of you. You guys got the correct answer. Um, so you can see you got 2 squared here, and then 2 and times 3. This one, it's actually the reverse. You try to take the highest possible. So this would basically just be 4 again. This would be 3 since you actually take the highest possible power, I guess. The highest possible power. You multiply these numbers together, you get 12. Good job, guys. Okay, next slide. Oh, okay. So we're on to the problems. I'll give y'all just type when you're done with problems, and I'll start when almost everyone's ready. Okay. Here's problem 1. I'll just read it out. 2 single-digit positive integers have a product of 72. What's their sum? Use remember to use a prime factorization for this one. Okay, I've seen most of y'all are done with this first problem, so let's get into it. Vivian, I see you. You said you were done first, so can you tell us what you got for problem number 1?
I got 17.
17. That's actually correct. Good job. Let's see how you got this. So 72. Let's remember to use prime factorization for this, okay? All right. So we know 72 can be divided into 8 and 9. These are literally single digit positive integers. You can just add these together, you get 17. Since they're single digit positive integers, and there are only 2 of them. So good job, Vivon. Okay, let's move on to number 2. Oh, we actually have an explanation here. Okay. Problem number 2. What is the least positive integer greater than 20? That is exactly 3 positive factors. Remember to use prime factorization for this, guys. Okay. Yeah. Same thing as usual. Just tell me y'all are done. I'll call on you. I'll call on the first person that responds. Okay, so most of you are about done. Ishant, you said you were ready with the problem. So can you tell us what you got for problem number two?
Just a question. Would one count as one of the factors or no?
Yeah, I think one does
Yeah.
count as a factor.
As a factor? Then yeah, I still need to think about it. Then I thought one didn't have to be one of the factors, but
Oh, it's okay.
It's fine. You tell us your answer.
without one, I got 24. But if it had to be with the one, maybe 22.
I mean, 24 doesn't work without one, two. Conflict. You have 8, 3, 6, and 4,
Oh yeah,
and 12 and 2.
yeah. But with the one, 22.
11, 2.
I think this is a pretty badly worded question. You can move on from this and move on to the next problem.
Yeah.
Yeah, it's not too clear. Okay, yeah, the answer was 25. So I didn't put one.
Okay. Okay, let's do this one. Lowest common multiple. This should be clear. At the gym, Pranay swims every 6 days, runs every 4 days, and cycles every 16 days. If she did all these three activities today, in how much days will she be able to do all three activities again on the same day? Remember to use lowest common multiple for this question. Yeah, same thing for all the questions. Just type in chat, you're done. If you have any questions, feel free to ask. I mean, number two was confusing. That's our bad. So, if there are any confusing questions you think might be low worded wrong, you can just say it. It's okay. Okay, so Lakshmanan. Sorry, I don't know how to pronounce your name. Lakshmanan. Can you? I seen you finished the question. Can you tell us what you got for problem number three?
48.
48. Oh, let's
Yeah.
sorry. Let's check your answer. Let's check your answer. Wait. Sorry. Okay, so he got 48. 48. Sorry, guys. Let me just draw that better. So we can split that up into 3, 2, 2, and 2. This one's a pretty big number. So 12 and 4. Also 2 and 2. That would be 2 and 6. Oh, sorry. So he got 40. He got 16, right? So 2. Sorry, guys. Wait. My bad, guys. I did it wrong. Hold up. So let's just look at what the explanation said. So the multiples of 4 are all of these up to 48. I mean, look, let's count. We count the multiples until we all get the same number, common number. So 4, 8, 12, 16, all the way to 48. Then 6, 6, 12, 18, count by sixes, all the way to 48 too. And 16, 16, 32, 48. Yep. So that means in 48 days, that would be the answer. Okay. Okay, let's just move on to question number 4. So let's say I want to plant 45 sunflower plants, 81 corn plants, and 63 tomato plants in my garden. And I want to put the same number of plants in each row, and each row only has one type of plant. So what's the greatest number of plants I can plant and put in one row? So just let's use, you have to use greatest common factor for that. So that means break it down, use prime factorization, break it down to prime numbers. Take the smallest power of that prime number, multiply it by the other ones, and make sure they're shared too. Okay. All right. Yeah, just message when you're done. Call on like the first or second, maybe even third person who replies. If someone hasn't replied yet, please try to reply for at least one question. Okay, Lakshmanan, seeing you've actually said you were done first, so can you tell us what you got?
I got 9.
9? Good job.
Yeah.
You're correct. So these are the factors of 45. These are for 81. These are for 63. And see 9 falls into all three. So you can put 9 in each row. So the answer is 9. Good job, Lakshmana. Okay. Um.
Can everybody please go to the link I sent in the chat?
Yeah.
Adnan, can you make a
Yeah, I'll
room?
host. Yeah, hold up.
Okay.
Create game.
Okay, the game code I'll send it in the chat too. What's the code? Just and we'll explain how to play once everybody joins.
Yeah. Okay, so you got Ashant, he joined. Vivan. Okay.
Oh, I think I typed the code wrong. Sorry. Here, I'll retype it.
No, they're joining.
Yeah, but I typed it wrong in chat.
Okay. Wait. Can the person who put the smiley face identify themselves in chat? Yeah, because I want to know the name. You can keep the smiley face. I just want to know who that is.
It's Verenum.
Who? Verena?
Yeah.
Okay. Oh, wait. I think she disconnected. I think she'll rejoin. Just type in chat if you're not in. We'll wait. But if everyone's in, we'll start.
Yojit, it doesn't look like you're in. Is it working for you?
I actually didn't get the link.
Okay, I'll send it again in the chat. All right. And Adnan, you know how to work the buzzin.live?
Yeah.
Okay, we'll just wait for Yojit to join. Yeah, you can remove them. Yeah.
Okay. Okay, Yojith looks like he joined.
Nihira, do you have a question?
Yeah, what does buzz mean?
Basically, yeah, I'll explain that now. So what happens is he'll show us a problem. Okay, can you unlock the buzz, Adnan?
Yeah, my bad. Okay.
Okay. So basically, can you guys see Adnan's screen?
Yeah.
So he'll show us a problem, and then you guys solve it. Once you get the answer, you click the buzz button, and as you see, I buzzed. So Adnan will call on me. I'll tell him the answer. So it's just whoever buzzes first, whoever solves the problem first, they can tell us the answer, and then they just get like a point. That's how it works in actual math counts. Do you have a question?
Yeah. Will the problem like show on the link or will it show like?
No, it'll show on Adnan's screen.
Yeah.
So you have to switch the tabs.
Yeah, I'll hear when someone buzzes and I'll just see who gets it.
Yeah. Okay, Adnan. Adnan, can you clear buzzers?
Okay.
Does everybody understand how to play?
I'll lock it so that no one just pre-fires, but yeah. I'll read the
No.
question, then unlock it, and I'll let y'all solve. Okay.
No, you can leave it unlocked, Adnan. I'll let you know who buzzes.
Oh, okay then. Okay. So let's look at this first problem.
Yeah.
So determine the prime factors of the following numbers. So 120 and 84. Use prime factorization for this. Yeah. Just have to list all the prime factors, okay? And you don't have to repeat them, just list like 1, 2, etc. Yeah.
Would we have to
Is this both numbers for one question?
No, no,
No,
no, separate.
No, sorry, 1 second. You have to get the prime factors of each number separately.
Yeah.
Okay.
And Ishant, I think you're unmuted. Might want to mute.
Oh, looks like someone buzzed.
Nihira buzzed. Adnan, you can stay on the slideshow. Nihira will tell you their answer.
Okay, tell me what you got. Nihir.
For A, I got 2, 3, 1, and 5.
2, 3, 1, and 5.
Yeah.
Okay. What about for B? You mind telling me?
I didn't do that one yet.
Didn't get that one? That's okay.
I didn't.
Let's see. So you said you got 2, 3, 2, 3, what and 5? 2, 3.
Yeah.
2, 3, and what? Wait, can you repeat your answer?
1 and 5. 2, 3, 1, and 5.
1. So actually, so you're close, but 1 is actually not a prime number since it's only divisible by 1. So actually, you wouldn't include 1 in your answer.
Oh.
It's okay though. Let's see if you got everything else right. So 120, you can split that into 60 and 2. Okay, whoever buzzed, we'll call on you for question number 2, okay? So 60 and 2. You can also do 2 and 30. Oh, whoops. Then you have 2 and 15. Then you have 5 and 3. So yeah, the prime factors would be 2, 3, and 5. Okay? Good job. You got it right, basically. Who buzzed second? Ishant? Could you tell us what you got for B?
I got 2 times 2 times 7 times 3, which is 2, 7, and 3.
Okay, let's check. So 84 would be 42 and 2. This would be 7 and 6. And 3 and 2. Prime, prime, prime. So 2, 3, and 7. Good job. You got it right. So I'll give each of you a point because you both got it right. So Nihir 1 point and Ishant 1 point. That's cool. Next. Okay, we need to define. Okay, you guys need to determine the greatest common factor of A
You
and
have to
B.
clear it quickly, like before you read out the problem.
Okay. Okay. What?
You have to clear the buzzers.
Oh, my bad. Okay. Well,
All good.
okay. So determine the greatest common factor of the following. So for A is 146 and 124, and for B it's 75 and 250. A and B are
I'm
separate
not quite sure
problems.
how to help you with that.
A and B are separate problems. Okay, don't get confused. Okay. Sorry. Whoops. Okay. All right.
Samit, stop.
Mhm. Oh, looks like someone buzzed. Let's see who that was. That was Lakshmanan. Okay. So do you have both A and B?
Yeah.
Okay, so what you get for A?
For A, I got 2, and for B, I got 5.
You got 2 for. Wait, can you say that again? So for A you got 2 and for B you got 5.
Yeah.
Um so for A so for A you got right but for B you got wrong. Okay? Let's just work on B due to time constraints, okay? So you got 75 and 250. Bro, okay. So we know that 250 is 25 and 10. 10 is 2 and 5. This is just 5. 5. Here you have what do I do? 25, 5, no, 25 and 3, which is just 5 and 3. I mean, 5 and 5 again. So 5 squared times 3, that's 75. 250 would be 5 cubed times 2. So, um, so you said it was 5, but that's just the number itself. We want the lowest one, but look, we don't have any 5 to the first. That would be, if there was, the answer would be 5, but the lowest one is actually 5 to the second. That's why our answer would be 25. You understand? Okay, well, I'm hoping y'all understand. Let's move on to this last one. Okay, so you guys need to determine the lowest common multiple of the following. So for question A, you have to do 84 and 48, and for B, you got to do 124 and 52. Okay. So yeah, when you're done, just buzz in your answers, and yeah, I'll call on y'all when I hear a buzz. This will be our last one. Okay.
Nan, you gotta clear the buzzers.
All right. All right. Yeah. Oh, looks like someone buzzed. See who it was. It was Yojith. Okay. So, what you get for A, Yojith?
I got 336.
And for B?
1612.
Yeah, she got everything correct. Um, okay, so let's see. Which one do you want to do? Let's do A. Okay, let's go over A. Okay. 84 and 48. So we're using prime factorization here. For this one, we actually need to take the highest power of each prime number. So let's see. Okay, that's the difference between lowest common multiple and greatest common factor. So 42, then we got 21 and 2, got 7 and 3. 48, you have 6 and 8. Then you got 3 and 2, and then 4 and 2. So then you have 2 squared. So this one would be 2 squared times, sorry guys, let me write it more clear. 2 squared times 3 times 7. This one would be 2 squared times 4 times 3. Oh, wait, whoops. Okay, so then we just have to take the highest powers of each prime number. Oh, wait, whoops. This would actually be 2 and 2. That means get rid of the 4. This would actually be 2. 1, 2, 3, 4. 2 to the 4th times 3. Okay, highest power, 2 to the 4th times 3 times 7. You get 16 times 3 times 7. That would be your answer. 336. Okay.
All right, I think the class is a bit past end time, so you guys can look at the explanation for the second one. But does anybody have any questions about like anything in the slideshow? You can raise your hand. All right, it looks like nobody has questions. Just for a note for everybody and all the parents, we are releasing a Google Classroom link that has the homework and the recording of every class. It's going to be on the Google Classroom, so make sure to check your WhatsApp. And yeah, that's it for today's class. Thank you for everybody for joining.
Thank you guys. Alright,
Bye.
bye.
Thank you.
You're welcome.
Thank you.
You're welcome. See you next week.
Thank you. See you next week.
You too.
Do we have any homework? Like,
Yeah, you do. One second.
Which where's the homework gonna be?
To be on the Google Classroom. Like I said earlier, we're gonna release it later to the WhatsApp, so all the parents and you guys can join the classroom.
Okay.
Just make sure to be checking your WhatsApp so you get the link to it.
thanks.
No problem. Verenum, do you have any questions?
Venom, you can leave now. You're free to leave.
Adnan, you can end the recording now.
Yeah.